All right, so I'm going to go ahead and do the difference of perfect squares. Now, if you have two terms, it could potentially, not always, be the difference of perfect squares. So with two terms, there are a couple things you look for. First off, you look at that exponent. If it's even, it could be a difference of perfect squares. Second, you look to make sure that there's a minus sign. Okay, so we're good there. As long as it's subtracting, it could be a difference of perfect squares. And then the third thing is you look to see if the numbers, the coefficients, are perfect squares. Okay, you know something's a perfect square if you can take the square root of it. So with the 4, square root of 4, I get a 2, so I get a whole number. 25, square root of 25 is 5, so I get a whole number. So we're good. They are both perfect squares. So difference of perfect squares are pretty easy. So to get 4x squared, or in fact to get 4, we just need to multiply 2 together. Okay, so 2 times 2 gives me 4. So that's my first term. I put it first in each one of these. To get x squared, I multiply by x times x. So my first term should be 2x and 2x. Because if you multiply those together, you get 4x squared. Now, since it's a negative 25, that tells me one number should be negative, one should be positive, because it's opposite signs. But 25, the number would be 5 and 5. Negative 5 times a positive 5 would give you a negative 25. And you'd be done. It's factored. So I want to do one more. For instance, this one. Now, if you look again, there's no subtraction sign in between, so that's one thing that tells us, oh no, maybe not a difference of perfect squares. However, regardless of the factoring technique you use, first thing you should always look for is the greatest common factor. So negative 50 and positive 8 are both divisible by a negative 2. I specifically am dividing by a negative 2 so that this first term becomes a positive number. I'm going to divide them both by negative 2. So I'm going to write that negative 2 in front, whatever my greatest common factor is. And then I'll have a 25x to the 4th power minus 4. Now, from the last problem, we know that 25 and 4 are perfect squares, so we're good there. So the only other pieces I need to check to make is the exponent. The exponent is even, so that's good. And then also we need to make sure that we're subtracting. And we are good there too. So when I factor this, that negative 2 should stay in front, that greatest common factor. Now, 25, we know that 5 times 5, the square root of 25 gives us 25. X to the 4th, we know that x squared times x squared, so I'm just doing half of the exponent, would give me x to the 4th. So that would be our first term in each one. So then I look at my second term. So we have our negative 4. Well, since it's negative, we know one has to be negative, one has to be positive. So the signs can be the opposite. And 4, we know 2 times 2 gives us 4. At this point, you would be done factoring.